In the last video, we saw how to solve linear simultaneous equations using the method of substitution, which was very straightforward. We just need to solve for one of the variables, and then we insert that value into the second equation and then do the back and forth substitution. Now in this video, I'm going to show you a different method called method of elimination. So the basis of this method is you need to align both equations such that all the terms appear one beneath the other. And then you can do either addition, subtraction, or you can manipulate one of them so that one of the values is going to cancel out. So in this case, what we can do is we want to have all the x's and all the y's aligned properly. So we can actually subtract x from this second equation on both sides. So we can write, so the first one is going to be x minus 2y equals to 1. And then here we're going to have minus x plus 5y equals to 2. So now the method is, okay, so how can we add or subtract these two equations such that one of them actually cancels out? And the simplest thing that we can do here is add these two equations, because that's going to get rid of the x straight away. This is going to be 0. Now 5y plus minus 2y, that's 3y. And then we have 1 plus 2, that's 3. So therefore y is going to be equal to 1. And now all we need to do here is we can just plug that value into y to find out what it is. So we can rearrange that equation so it becomes 2 plus x divided by 5. And then actually we need the value of x, so this would be a little bit silly. So let's just leave it as it is, but we're going to rewrite it as 5y minus 2 is equal to x. Therefore x is going to be equal to 5 times 1 is going to be 5 minus 2, that's going to be 3. Alright, and you could check this by just plugging those values into the both of them, and you should see that the equations are indeed satisfied. Or you could use the method of substitution and you should get the exact same answer. So it's up to you to choose which method you prefer. Personally, I prefer substitution because it's a lot quicker and you don't have to do too much manipulation. But I guess different people prefer different things. So I guess it's worth trying both methods to see which one you find most useful. Now let's do some more examples with these ones. So for question B, we're going to have 7x plus 2y equals to 8. And then 3x minus 5y is going to be equal to 21. Now this one is a little bit trickier because, as you can see, there's really no way that we can get rid of anything by just adding or subtracting. We actually have to manipulate these equations in such a way that we eliminate one of the variables. So let's see what we can actually do here. Let's say we wanted to get rid of that y there. So this one is a 2, that's a minus 5. There's nothing we can multiply this with, no whole number we can multiply this with to make it equal to 5. So we could either multiply by a fraction, or we could multiply each of these by a different whole number. So for example, we could multiply the first one by 5, so this would become 10. And we could multiply the second equation by 2, so this also becomes minus 10. So let's do just that. So the first one by 5, this becomes 35x. This is going to become plus 10y. Equals to 8 times 5, which is 40. Remember, we're allowed to do that because we're doing it to every single term in that equation, so that's perfectly fine. The equation is still satisfied. Now for the second one, we're going to multiply everything by 2, so that's going to be 6x minus 10y, and this is going to be 42. So what can we do with that? Well, we can actually add the two equations together, because that way the y is going to cancel out. So we're going to be left with 41x, and then here should be 41x plus 0 equals to 40 plus 42, that's 82. So x is going to be equal to 82 on 41, which is equal to 2. And now to solve for y, all we need to do is we need to plug it into one of these formulas. So let's plug it into the first one. So we have 2y is going to be equal to 8 minus 7x, and then y is going to be equal to 8 minus 7x divided by 2. So if we put 2 in this equation, we have 8 minus 7 times 2 is 14 divided by 2. Okay, so the top is going to become minus 6 divided by 2, which is minus 3. And that's going to be our final values for that system of equations. And we can check that those are the correct answers simply by plugging back into the two equations and making sure both of them are satisfied at the same time. Now let's look at another example just to get you more comfortable with this process of elimination. So let's have 5x plus 7y equals to 1, and then 3x plus 5y equals to minus 1. So once again, we cannot really add or subtract them directly. We need to actually make one of those coefficients equals to the other. And because this is not a multiple of that and this is not a multiple of that, we cannot really just multiply one of them. So what can we do in this case? Well, we can do the same thing we did before. We need to choose one variable to eliminate first. So how about we eliminate the x first? Now, we could multiply this by 3, so that becomes 15, and then if we multiply this by 5, that becomes 15. So let's multiply the top by 3 and the bottom, but this would have to be negative, or we could just subtract the two equations. You know, let's just do a positive number in this case. So let's do times 5. So let's rewrite the two equations. This becomes 15x plus 21y equals to 3. And then the bottom one is going to be 15x plus 25y equals to minus 5. And now instead of adding them, we're going to subtract them together so that these two elements are going to be eliminated. This becomes 0. 21 minus 25, that's minus 4 times y. And we have 3 minus minus 5, which is going to be 3 plus 5 is 8. So that means that y is going to be equal to, so 8 divided by 4, that's minus 2. And now we're going to plug this back into one of the equations. So let's do this bottom one. So 3x equals to minus 1 minus 5y. X equals to minus 1 minus 5y divided by 3. And then if we plug in that value, that becomes minus times minus is plus. So that's 10y. So minus 1 plus 10. Actually, it's not 10y, just 10 divided by 3. That becomes 9 divided by 3, which is 3. So x is going to be equal to 3, y is equal to minus 2. And once again, we can just check that these values satisfy both equations at the same time to make sure that our answers are correct. So then again, like this method it's similar to what we do with substitution, but instead of actually just substituting an equation by rearranging terms, all we're really doing is we're just manipulating the equation so that one of the terms eliminates each other once we add or subtract equations. And then it's up to you to decide which one you find most useful. But I think it's good to know both of them in case you're given an equation that is already very easy to manipulate just by adding or subtracting terms. So I guess it's just a matter of practice and just deciding which one is the most useful for you.